Welcome, everybody. Welcome. We are
Hello.
so excited to have you here today for our live webinar all about data, beekeeping, all the big changes that we're making in the world. So we're just going to give it a few minutes for everybody to join. And in the meantime, we want to learn about each of you today. So please feel welcome to use the chat, share where you're from. In the meantime, in a couple of minutes, I'm going to invite Delaney, who some of you have attended our webinars in the past might be familiar with. She'll launch a survey. We'll just give it a couple more minutes for everybody to join. But again, use the chat. Let us know where you're tuning in from. Let us know if you have any beehives or even if you have any questions. We'll see if we can keep an eye out for those so we can track how to answer them to the best of our ability.
Great, thanks. Thanks for joining. Hi, everybody. Welcome, welcome.
Whoop, whoop.
Massachusetts certainly represented.
Yeah, coming through. Colorado, LA. I hope it's warm in LA today.
I'm in this sunroom and it's like 40 degrees out, but it's really warm in here. And it just like reminds me, that's why you have a sunroom, to just let all the light in. And I don't know, it's really, really nice.
That's great. And for those of us without a sunroom, we can just close our eyes and picture Nate, picture joining you in Maryland in a beautiful sunroom. We've got a sunroom in our minds, especially talking about bees all the time.
Absolutely.
All right. Well, I'm going to throw it over to Delaney now. Delaney's going to launch a survey so that we can learn a little bit more about each of you attending today. So why don't you kick that off for us, Delaney?
I will do that if it lets me here. All right. So launching a poll. You guys should see the questions pop up. We have two questions. The first is, what best describes your relationship to Best Bees? You want to know who's here. Are you an industry partner? Are you a current client? Are you just a friend of beekeepers, employees, things like that? And then what's your favorite thing to pair with honey? So I'm going to go ahead and launch that. I'll give you guys, we'll call it a minute, give you guys a minute to throw in some responses. Nate and Noah, why don't you guys tell me what your favorite thing is to pair with honey while we let folks answer and drop in their questions.
Do you want to take it first or should I jump in?
Go for it, Nate.
Okay, because it actually doesn't let the panelists vote, and I was so excited to vote for this. So, okay, my favorite thing to pair with honey is got to be coffee. And I do that most times, but I drink it black with a little bit of honey. I had a beekeeper from Colombia told me that was the best way to enjoy your coffee. And 10 years later, he's right. That's how I'm enjoying my honey most of the time, is with coffee.
So good.
I love that. A sustainable sweetener. Mine is included on here. I remember in our rehearsals that it was not, so I'm glad to see that in there. It's ice cream. I love adding honey to ice cream. It gets hard and chewy in this way that it's kind of like hot fudge. I mean, nothing compares to hot fudge, but it's a little bit healthier, a little bit more sustainable for a topping, and people don't really know about that. It's kind of a pro tip.
That's really interesting. It kind of, is it like crystallized honey a little bit? It like in the way it like transforms its texture?
Yeah, it just adds a little bit more dimension. I like chunky ice cream, so that helps. Maybe I'll try yours, Nate, with coffee. I've never done that. Have you ever tried it with ice cream?
No, and I'll try yours.
Okay.
It's got to be vanilla.
Look at this partnership live. Everybody's watching it right here. We'll report back at our next webinar how the coffee and the ice cream went.
I'm on Team Nate for this one. Honey and coffee is the absolute best. That's what I would vote if I could also vote, which I'm not allowed to. All right, well, I'm going to end the poll. It looks like 50 of you answered our questions. It looks like I'll read off the results and I'll share them so that you guys can see them. But it looks like 32% are current or past clients of ours. So welcome to all of you who have hives and work closely with us. We're so happy that you're here. Another 32% is in other. I should have added a description to this. So all those other folks out there, it looks like we've got a lot of folks from Best Bees and a lot of industry partners. So welcome to everyone. All right. And now the answer we've all been waiting for. The number one favorite thing to pair with honey from our attendees is tea at 26%. Honestly, didn't see it coming, but it's a good one. 18% with cheese, which I do love a honey and cheese moment.
I love that. And hey, I hope that you guys are learning now already, considering that 0 of you put ice cream.
I
That's
know,
great.
Noah.
Yeah. And then coffee's
Vote.
next. Now you guys know you're already learning from us. Try those things. And I love actually seeing so many people from our Best Bees employee family who are tuning in, because we're always learning from each other. And we always say one of the values at Best Bees is inclusive innovation. So anybody share observations, ask questions, test hypotheses together. It's really part of what we're doing today when we're coming together and sharing with you how we approach research and science and data and community building, and hopefully inspiring some of you. So those are some of the topics that we'll share today. And again, I just love that everybody, even from our team who's already doing this research, is tuning in, because we really learn from each other every time. I always learn every time I talk to you, Nate.
Hey, same here.
Awesome. Well, thanks everyone who took the poll. I'm going to hide my face for a little bit, but I'll be rejoining in a while, and I'm going to pass it over to Noah to get started.
Thank you,
Thanks.
Delaney.
Right on. All right, let's get started. So I'm Noah Wilson Rich. I am the CEO and the Chief Scientific Officer here at the Best Bees Company. I co-founded the Best Bees Company in 2010 with a goal of leveraging all of our client beehives to fuel my scientific research. Now, for those of you who have been following the Best Bees story, back in 2010, I started this as a way to get more beehives out there so that I could do more research. And I was testing and developing vaccines, probiotics. We were calling it bee yogurt at the time. I was doing these studies called palatability to see with these oral vaccines and treatments how the bees found them tasty or not. Because for any of you who have kids, if you're trying to feed something medicine and it doesn't find it tasty, it doesn't matter if it works. You can't get it in their body. And so a lot of these different approaches to science are how we've been able to do something really remarkable, I would say, which is to move the needle on our mission to improve bee health. And Best Bees beehives are outperforming the national average by a really high amount these days. So we're making progress, and it's all part of citizen science coming together, people, companies saying, hey, we want to support, we want to make an impact. We look at the news every day and we see these heavy, depressing headlines, and we want to do something. So often getting a beehive that's connected to a research network, like what we do at Best Bees and at our partners like our nonprofit Urban Bee Lab, these are all ways that as a community, we come together and we can make a difference. And it all helps to advance scientific research. So that's what we're going to share with you today. Now, 12 years later, going into our 13th year, I lead our scientific team. We have a team, and Nate is here to share a little bit about what we do there. Nate today is going to share with how this research helps improve the boots on the ground best practices for the gold standard in beekeeping. And I'm here to share with you a little bit more about the scientific research and how we're really advancing that with peer-reviewed publications and other presentations. So let me pass it over to you, Nate.
Great. Thank you, Noah. I love that term you said, citizen scientist. So I would identify myself as a lifelong beekeeper, but early on, I kind of latched on to that concept of being a citizen scientist. I wanted to take my experience outside of just my backyard and feel connected with other beekeepers across the country. So a little bit about me, I'm a lifelong beekeeper. I've spent the last 8 years or so in commercial scale beekeeping and research. And then just last year, I got my Master Beekeeper certification through the Eastern Apicultural Society, which is something I'm kind of proud of. But now I am the head beekeeper with the Best Bees Company, and I'm really excited to dive into this today with you to figure out and really just kind of show you a little bit underneath the hood how we're taking this data and how we're applying it in the short term and the long term, and how that relates to the beekeeping and management practices that allow us to maintain this huge network of bees across the country at this really sort of high quality level. And so, yeah, I'm excited to get into it today with you, and I'll pass it right back.
Yeah, I love that. So also, I just want to acknowledge and go off script for a moment. We are a couple of white guys who are presenting this research. We are today presenting a face for beekeeping and how we're making an impact to improve bee health, how we're able to build community. But we really, really value diversity, equity, inclusion, belonging. Our team is a certified diverse vendor. through the LGBT Chamber of Commerce. So we take diversity really seriously. And even though Nate is representing master beekeepers, as you shared through Cornell and other programs where we're promoting education and equity and access to these degrees with my PhD in honeybee immunology, these are things that we're representing today because this is what we do as just members of a much larger team of over 100 beekeepers across the country. And we're really trying to reach out and build opportunities within the communities that we serve in over 20 cities across the United States. So even though, yeah, a couple of white guys wearing by chance matching blue shirts today, just acknowledging that, this is who we are and what we're doing. And we don't represent everybody, but we're speaking our truth. And we really value building community in a diverse way that reflects the areas that we serve. So I just wanted to acknowledge that too. Now, today, we're going to cover a lot of ground. We're going to start by sharing how our data has evolved in terms of how we collect it at Best Bees. And then we're going to share what we do that's very unique. We call it standardized beekeeping. Now, I'll tell you what that is and how it's so helpful to compare with other data sets as we build community across scientists and create a network. Now, we're going to share how we monitor the data and how we analyze it and what we've learned. And then we're going to open it up for a bit of a discussion with questions from you and have some fun. All right, so let's get to it. If you have any questions, again, during the webinar, we've got a different function just aside from the chat. It's the Q&A. So use the Q&A feature of Zoom, and Delaney's going to work to answer questions as we go, and any other questions are going to be answered in the Q&A portion at the end of the event. So chat, go ahead and use that. That's for sharing comments and where you're from and other things. Questions, put that in the Q&A in Zoom, and share questions for the end. That's where we'll get to some of them. All right, let's dive in. Now, here's a bit of our flow chart for what we do with Best Bees and with our commercial co-venture relationship with our nonprofit. It's a charity research lab called the Urban Bee Lab. We look at the scientific method, which starts with observations. And this goes back to our core value of inclusive innovation. We create jobs for beekeepers within their own local communities to install and manage beehives and to take observations for how they're doing. We're building on the thousands of years of human knowledge and experience with honeybee hives and beekeeping. Honeybees are the gold standard model study system for understanding pollinator health. They're indicator species, meaning they're telling us how the ecosystem is doing in terms of pollinator health. And it's up to us to listen to that, to observe that, and to understand that there are 200,000 species of pollinators out there hard at work every day, visiting flowers, producing food for us and other animals. They're also helping to promote plants that then take in carbon through photosynthesis, helping a lot of these net zero goals that many companies are working on and that our scientific team is incorporating into our other data reports in terms of carbon recapture and pollination. All of these come down to observations as the first step. And so whenever we're seeing how a beehive is performing, we work with our proprietary data system, which is in smartphones that we write the code for with our software engineering team. We've always had one in-house so that we're recording what those observations are. From there, we ask questions. Why is that beehive doing great? Why is that one not doing great? And then we come up with an answer, an idea for what the response could be, and that's a hypothesis. So to test that we have the right answer in mind for what question we're asking from these observations, we're collecting data, and that's the second part. So data collection has always been core to who we are at Best Bees, and it's honestly always been what's very different about us, because now, going into our 13th year, we have the largest data set and the largest data network of these research beehives that exists anywhere in the world using standardized methods, meaning all of our beekeepers are doing the same things to control the methods that are with beekeeping practices. For any of you who are beekeepers or who know beekeepers, there's a saying that if you ask 10 beekeepers a question, you get 11 different answers. And then some beekeepers will say, no. If you ask 9 beekeepers a question, you get 10 different answers. And we say, that's exactly what I'm saying. So there's a lot of variation, and we standardize our practice so that the data we collect are uniform. We're reducing the variation due to operator error. Any survey data, for those of you who are scientists, can be very noisy. There's a lot of variation because when people are self-reporting data, they're doing the methods in very different ways. So we're observing what the bees are doing based on our standard practices all across the country. And then we're collecting data on how those beehives are performing. Nate's going to share a bunch of those different measures in a moment. We then partner with our nonprofit to analyze those data and then to report them in ways that are accessible. So for our publications, we really value open access journals, like Frontiers is one that we've published in before. We currently have an article and review from how all of our beehives are doing. Are doing. And then we report in creative ways. You guys are familiar with our TED Talks, our book with Princeton University Press. We just had a museum exhibit at the San Francisco Museum of Modern Art showing our space capsule where we launched bees successfully. So anything we do, we want people to be able to access. So for example, at our nonprofit website, urbanbeelab.org, you can see a map of the world and some of the data from our network of these data yielding beehives, so that any other beehive that goes out there, we want to inspire beekeepers and any other beekeeping services to understand how to collect data to really make an impact. And we really want people to join our data network by getting one of these Best Bees beehives, because if it's not connected to this network, it's not really going to be accurately compared to other ones in this standardized way. So we're going to deep dive this a little bit, but once we report those results, they inform two things. And this is where Nate and I are going to share from different perspectives. They help us implement best practices on the ground for beekeeping, applied science, we call that with Nate. And then they also help to advance scientific research in a very basic, fundamental way. So that's what I'm going to share too. So with that, let me share a little bit over what we use to actually track all the data by hand. Now, I've shared with you that from day one, we have used this proprietary software called Buzz, and this is something that's not available for public use. It's really something that we write in-house so that we can tweak the questions anytime we see a different observation, and we want our field beekeepers across the country to collect, let's say, a different data set for a new hypothesis. We can then update our software so that our beekeepers are doing the same thing and they're answering the same questions and recording the same data as that may change. And you can see in this image, there's a little graphic from one of our field scientific beekeepers collecting data in real time, and our software will produce graphs for honey yield, for brood, it's how many baby bees, for adult bee population. We can see how a lot of these different variables change over time. And so that's really helped to advance our ability to incorporate technology in a way that can improve the quantity and the reliability of the data that we collect in the field. So I know I've covered a lot here, but Nate, let me throw this over to you. What are some of your thoughts for how these data have helped improve your own practices?
Well, when I think about our approach to data, I think at the core of it is, well, it's essentially research. We are a research company. And when you go back to the etymology of the term research, it's really to go back and search for the truth. And so that's what our approach is all about, season over season. We're going back and researching, like you said, hypothesis. And are we going to change things up about what we collect? So, there's long held beliefs in beekeeping that we continue to test year in and year out. And we just want to continually research them so that, if these long held beliefs are changing or there was a misunderstanding, that's what we're uncovering. And so this past year, I actually worked with our engineering team to incorporate several new data fields that we'll get into a little bit later. But these new data fields that we added, I think, leverage our biggest asset, which is our on-the-ground beekeepers. So long-term, a lot of points have to be distilled down into zeros and ones. Does the hive have a queen? Does it need an extra box? Did it produce honey? But they all add up to produce trends that paint a sort of roadmap to colony health and just as informative, colony failure. So most beekeepers will tell you, though, that when it comes to beekeeping, there are going to be plenty of gray areas where the condition of a colony doesn't exist as a data point, as just like a 0 or a 1. So when we give the beekeeper the ability to sort of convey the condition of the hive outside of this black and white picture, we can more quickly and effectively correct the trajectory of that hive so we can continue to sort of research its evolution. And that ties into our approach to standardized beekeeping. So I actually had this question myself. What exactly is standardized beekeeping? Because I know what traditional beekeeping is, so how has standardized changed anything? Well, when we think about our approach to data, we have to have some synergy with our approach to hive management. So we're asking the same questions to every beekeeper across the country. And in order to make that data set the most reliable that it can be, we're also going to standardize how they manage the hive. So essentially standardize our beekeeping. Now, a standardized beekeeping, if I was to sum it up, it's an approach to sort of control or document as many variables at the hive level that you can. Now, there are inherently different variables across the country that aren't standardized for every colony. As you well know, we have our rooftop hives, we love our rooftop hives, and we have ground level hives. And then we have hives in different corners of the country. So there's going to be geographical differences there as well. But within those subsets, we have certain protocols. And a protocol is a step that a beekeeper can take at the hive that we do the same across the country. So when we take those protocols and we adapt to the variables in the field, long term, that allows us to sort of prioritize the health of the colony while still maintaining that reliable data set. We learn from our successes, we learn from our failures, and we adapt the beekeeping as well as the data approach while keeping research at its core. And traditionally, beekeeping, like in my backyard here, is rather intuitive. Year over year, you just kind of respond to what the bees are doing, and you might not be documenting it, and it's not connecting to any other network. So, I told you earlier, I really wanted to be a citizen scientist. I wanted to take what I was doing and see if other people are doing it the same way or if they're learning something different. Now, there's other data sets out there, but nobody's applying this standardized beekeeping to it. So when we take our research approach to data collection and we take our standardized beekeeping approach to hive management, we yield this really reliable data set that helps us sort of pinpoint what is keeping colonies healthy and also what is a big challenge for colonies as they progress through the year. And that's, I think, the best way for me to summarize standardized beekeeping.
Yeah, I love that, Nate. And it really reminds me of the earliest days of Best Bees. I am not a control freak at all. I would hope people would say that too. And for those of you who are out there who are control freaks, like, I get it, it's all good. But that's not why we standardize it. It's because of my scientific background and thinking, okay, what are all the variables? For ecology research, when we're collecting data outside, there are so many variables out there, the weather, pollution, pesticide. It's like so much to study. And so the least we can do as scientists, and this is something you've really advanced, Nate, with our bee school for our training program, and everybody's in it. And we all say across the country, okay, here's what we're going to do now. We're going to do the same thing with this visit. And anything that's a variable, we know that's up to the bees or that's up to other factors. So we've come a really long way. And that's even, I would say, another thing that's proprietary with Best Bees. Any beekeeper can put a beehive on somebody's yard or on a rooftop. And that's a great thing so that there's access to pollinators and to beekeeping and even to their own research. But it's when you join a network like what Best Bees has developed that you can really have that one or two or that apiary of beehives make an impact and move the needle, so to speak. So I'm going to share a couple of these different approaches as we now split and advance this topic for how we can use this data to implement impact. A lot of companies have ESG goals and they've got biodiversity requirements now put on them by investor demands, and they don't really know what to do with that. So we've been able to split this into two different channels that we're going to cover today. Our first role is how our data inform our beekeepers and beekeeping team in the field. And then our second is how this informs our scientific team. And this can explain a lot because we're combining data with advanced knowledge for a bigger global purpose. This can advance policy, this can inform laws, in addition to other ESG goals. I mean, we even presented this last week as part of a video for the United Nations COP27 conference. So there's global impact, especially when you can amplify the work you're doing on site by connecting it to this larger network. So Nate, traditionally we're using a lot of data for knowledge, but how has this advanced your practices on the ground? How does this really make a difference?
Great question. First, I'd like to take a step back and ask for you to imagine a 12-month calendar in 2 seasons. As it relates to a beehive, there's 2 seasons: expansion, when the hive's growing up and getting bigger, and contraction, when it's sort of paring down and getting ready for winter. Now, we think of seasons as spring, summer, fall, and winter, right? So the expansion and contraction seasons for honeybees fall within those spring, summer, and fall and winter seasons, about 90-day intervals. So when you think about these sort of 90-day intervals, you're thinking about the evolution of the colony throughout the season. And when we collect short-term data, and the short-term data that we do collect throughout the season applies to the colony's evolution. So if a colony is queenless, let's say in spring, we're going to operate a different protocol to get that hive a new queen. And if it's queenless in September, we're going to operate a different protocol than the one we would in spring to get that hive healthy and through the winter. So it can be tough to predict, but the weather, it can be tough to predict the weather, but the colony doesn't lie. So these like practical approaches to beekeeping, or this practical application of our data, it really involves aggregating it all together for, like you said, the variables that we can't predict. And a lot of times that's going to be weather. But I want to jump right now into a term that I just dropped for you, short-term data. So short-term data is all about managing the hive for continuity. And hive continuity is, simply put, the length of time that a colony of honeybees is continually functioning as a superorganism. So I just mentioned the example where the hive doesn't have a queen, and that can be anywhere between a 3-week gap to a 6-week gap. And what we started to recognize is that as we close that gap where that hive isn't functioning as it's supposed to, we're seeing an increase in hive longevity. And I'll get to that in a minute. But when we look at the short-term data, I want you to think of hive continuity. We're trying to keep that hive on its trajectory to get through the winter and the seasons beyond. And some of the data points that we look at when we're considering short-term data and we're focusing on hive continuity is queen status. Is she thriving, or is she sort of on the struggle bus? One of the new fields that we added this year is the hive condition. It can relate a multitude of scenarios and just any number of things that will relate to the hive being on its right path. So let me jump into it right here with this screen in front of you. Queen status. Now, when we're looking at these short-term data points, these are probably the 5 biggest ones that I'm interested in. So we look at the queen status. I talked about that. We're going to look at the frame count. And the frame count is the frame that's actually inside the hive structure. And that's how beekeepers sort of manage, because these are managed pollinators. The beekeepers manage the size of the hive. The colony is the superorganism. The hive is the physical structure. And so frame count is something that we pay attention to very closely in the short term. Then we have brood count. As Noah said earlier, those are just sort of baby bees waiting to be born. And there's some interesting math that we figured out. We can sort of predict the size of a colony in the future based on its brood count. Honey stores, we all love to talk about honey stores. Is my hive producing lots of honey? Is it producing little honey? Is it in a zone over here where all the hives are producing lots of honey? So that's a really fun one to stay on top of and get throughout the season. And then lastly, we have the mite counts. We'll get into that a little bit later, but as a short-term and a long-term data point, mite counts are very important. And our beekeepers know how to take mite counts, and it's a great sample for sort of where the hive is at during its evolution. But that's short-term data. That's how we're applying it. That's how we're collecting it. And I just want to pass it back to you, Noah, for a little bit more on how we use it for the knowledge side of things.
Yeah, I love that, Nate. And thanks for running us through that. Nowadays, we collect 77 different data points on our beehives. We started by collecting 3. So you can just see how our science has advanced. I mean, maybe it's overly complex, but I think it's really important to get a full holistic picture of what's going on. And especially now that we have a science team built out and an R&D department for innovation, and we're working with our clients to listen, what are your ESG goals? What are things that you're working on? How can we tailor your reports to really help advance the things in-house that you're trying to achieve? Those are ways that we've been able to leverage all the different data points that we're collecting in a way that actually makes an impact. I think going into COVID, a lot of different companies at conferences, I was hearing talk about data collection, how important it is. And then people would start to laugh. I remember this was at Greenbuild in San Diego 2 years ago, because you can collect data until the cows come home, but what are you going to do with it? How do you analyze it? How do you report it? How do you build community and make an impact? So for us, one of the approaches that we've done is we've worked with our partners. And so that's been really helpful to connect the innovation with kind of a gut check with, say, like, is this relevant? Our R&D department meets with our marketing department regularly so that we can help together try to communicate what we're doing and see, is this landing? Is this on track, or should we kind of regroup here? So I think it's really important that we lend ourselves to different partnerships. I've shared with our nonprofit, but we also have a lot of different approaches that value collaboration. And one of my favorite projects we call blue zones, and that also relates to what we call red zones. Now, blue zones is a term that some of you have heard us use over the years because we've been refining it, and it's a model for us to understand pollinator health. Now, again, we use honeybees as an indicator of ecosystem health. So on our map of these data yielding beehives, where all of the best bees client hives are across 22 cities in the US, we're seeing where the bees are doing really well, where they're outperforming the national average, and where they're not doing well, so where they're underperforming. And the areas where bees are doing great, we call blue zones. And that's a term taken from human health, where there are many octogenarians, people who have long lived. And I believe there are about 5 blue zones in the United States, or in the world, for human health, notably like Japan and places in the Mediterranean. It's often attributed to a healthy diet. And so we apply those concepts to bees. In areas where they don't do well, we call them red zones. And we've been able to have an amazing partnership, for example, with NASA. So with their Earth observation satellites that are constantly looking down on the Earth everywhere, and they're recording data on weather patterns, on elevation, on greenness, how green an area is, we're able to be their boots on the ground, or their wings on the ground, or the beehives on the ground, to be able to give some more richness to our understanding from the data collaboratively with the government. This year is the first year that the Best Bees Company has been a vendor for the federal government across sites nationwide, called Pollinator Analysis. So our contract is putting these data yielding beehives across government sites to join this established network to see where bees are thriving and where they're not. Because if a honeybee hive is not thriving somewhere, that likely indicates that other pollinators are not surviving there well too. And that's something that we take very seriously. We're trying to understand what the bees are telling us and what that could mean for other pollinators. And as we advance our research with another group that I'll share with you in our next slide, with Simmons University, a local all-women school in Boston, we're able to collaborate with our genomics technology. We're always implementing different technologies, from even blockchain to augmented reality and machine learning. So with genomics, when we look at the DNA of plants in our honey, we call that honey DNA. And that's what's at urbanbeelab.org. So any Best Bees beehive, or even a citizen science beehive around the world that joins our research network, you can see on that website with our nonprofit what the local pollinator plants are. And then as a local community all around the world, you take a look at that list and you discuss the data. And you say, well, what's really relevant for us here? What's a native plant we want to pull out? What plant is good for other pollinators? Let's say like a local species of milkweed that can benefit the now endangered monarch butterflies. Milkweed's also pollinated by bees. There's a lot of overlap there. And through data, we can build community at the local levels by sharing this information freely. With Simmons, we're now creating those pollinator plant habitats, cutting the flowers, looking at the animal DNA to get a list of the animal biodiversity that's on a local area. So we can see all of what I call these cryptic pollinator species. We know that there are typically hundreds of species of bees in any given area across the United States, but we don't know what they are. Even for a PhD in bees like myself, I can name like 5 species of bees. So when we get this list of animal DNA that we get from a flower that we've planted, we now can see a list of the bee biodiversity, and we can see all the different species of pollinators that are visiting our habitats and know what they are, and take a look and say, okay, well, what are the native ones? What do we want to pull out? For example, the blue orchard bee has been something that Best Bees has been working with for about a year now, and they're very cute for a bee. They're a little bit blue, and they're great pollinators. And so when we understand what those native species are, we can then figure out what habitat for nesting to plant for them. We amplify our impact by working together. So with that, I've got a lot of examples to share, but I want to pass it back over to you, Nate. How can you bring this back home in a way that really applies to beekeepers?
Well, I mean, I think the biggest thing when we start to look at larger trends, I told you I was going to introduce another term to you, and it's called hive longevity. And so when we think about hive longevity, it's kind of like that blue zone idea, right? We're seeing people live longer in certain areas, and we're trying to like reverse engineer it and figure out why. So when we take a step back and we look at these larger trends and we say, okay, what is the hive longevity? How long are these hives lasting? Is it 6 months? Is it a year and a half? Is it longer? Are they functioning again and again, year over year? And I think one of the big ways that we're measuring that is through, we're doing mapping around the hive at the hive level to see what its access to nutrition is. we're taking sort of those hive continuity points and that short-term data, right? So we think of hive continuity, we're thinking of these hives operating, functioning as a superorganism, the queen's there, and we're aggregating that over the season. And then we're looking at it for longer term trends. So while it's tough to, get into the moment and try to see the bigger picture, that is something that we're able to do because we have this network of beehives across the country. And that's one thing that I'm really excited to continue to research on, is the things that we can add in terms of data points that will sort of help us figure out exactly where are these blue zones, where are hives living the longest, and more importantly, why are they there and what's causing them to be that way, and can we replicate it? But I'm really curious, Noah, if you were to sort of pick an approach to your knowledge base, what are some of the other data points that you're looking at that aren't short term, that are maybe they're long term, but maybe they're not as sort of like hands-on, boots on the ground type of things?
Yeah, I mean, of the data that we collect, I mean, we're always looking at productivity and we're looking at reproduction. And I conveniently for the next slide here too, we kind of summarize it into three things. And this is like the last big outer space, big research approach that I want to share before we regroup and then take it back down to earth here. For all the things that we're looking at, we're thinking about what is the best for survival for beehives. So how do bees reproduce? How do they get genes to the next generation? So we always look at the queen health and queen reproduction. And we're looking sometimes at the color of the marking of a queen. I don't know if everybody here knows that for beekeepers around the world, certainly in the United States, that there's a different color of paint that beekeepers agree upon to color for the year that that queen was made. So we can track how old the queen is. Queens can live up to 5 years, although these days, especially with new research that just came out showing that queen bees are living much less than that. So every year that color changes. And I think that's really exciting to see a color marking on a queen from 4 or 5 years ago, to think, wow, this queen has been around a really long time. We call the queen's production evolutionary fitness. As a basic scientist, we're always thinking about fitness and how to get genes to the next generation. And let me take a step back. For any of you who were sitting around for years in lockdown, which is all of us, and you're thinking, how am I doing? How's everybody else doing? That's what we think about with fitness in terms of getting our genes. How are we reproducing? How's my family doing? What's happening next door? How do we compare our wellness and our health and our production to other organisms, kind of as a relative amount? And so we think about fitness in terms of reproduction. We think about fecundity in terms of the potential of reproduction, or how many eggs the queen might have, how large the queen is, her ability to reproduce. And then the productivity, honeybees give us a really unique opportunity to measure productivity. Like some of you at work are thinking, okay, well, I got to get back to work. I'm joining this live webinar with Nate and Noah because they're cool. Yeah, thank you. I love that. And other ways to measure productivity in the field, like with honeybees, they make honey. They make so much honey that for bee scientists like us, it's a pain in the butt. We don't want the honey. So it's been amazing to give all of that honey to our clients. They keep all the honey ever since day one. We're not a honey company. Anytime somebody wants to buy some honey from us, we say, get the bees. The point is to get research bees out there, deal with the honey later. Even with the federal government, they give the honey to local food banks in the community. So there's so many fun ways there, but for us, we measure how much honey is produced. So we're taking these 3 key basic science measures, in addition to all the practical beekeeping measures that Nate's working with, to get a much more holistic approach for how the bees are doing, where they're doing best, like with blue zones, how to partner with other institutions like NASA to give us a more holistic picture to see, okay, what's happening around these hives. And then we're finally able to make an impact, for example, in an ESG report or a biodiversity report back to any stakeholders in ways that I think are really fun. And it's been amazing to build community around this. So let me jump back in here. We're going to share with you guys some learnings from bees. And Delaney, I want to invite you back in to help guide us through.
Awesome. Thank you both so much. This has already been so fun to listen in and learn more about what both of you are doing day to day. All right. So we're getting into the learnings portion of this. Nate and Noah and I decided to pick 3 categories where we've had some really amazing insights over the past year, and they're both going to share from their perspectives on these categories, what we've learned. So we're going to start first with the hot topic of varroa and mites, and I'm going to let Nate start us off. Nate, what have we learned? I know this is a tough one to start with, but
Oh, it's a tough one to start with, but we're going to finish on a great note. So I'm happy to just sort of like put this out there and get it out of the way. Mites are tough. Mites have been around. Well, honeybees have evolved for millions of years, but mites in the US sort of came over in 1987. Coincidentally, that's the same year I was born. So I've never known a year of beekeeping without mites. So I've had a lot of learnings over the years. What we're seeing this year and specifically is that despite using our organic controls to combat the varroa mite, they still are so prolific. And then they transfer in a term called mite bombs. They transfer from a weak hive to a stronger hive through a process that's known as robbing. And so we're seeing some high mite levels later on in the year, even after we've done a fantastic job, in my opinion, of working to control the mites. And then that leads to a high viral load. And then you will see bees just sort of up and abscond. They say, I'm kind of too sick to be around all my sisters and my few brothers and mom, and I'm just going to go away from the hive and not return. Some people might call that CCD, but it's in fact, it's absconsion through high viral load from the mites. And that was one of our big learnings from this year.
Yeah, let me jump in here too. Our latest research manuscript that we submitted was called "Why Are Our Bees Dying?" And it's a big question that everybody's still asking ever since colony collapse disorder first started around 2006, 2007, when bees were vanishing. So people care about this, and it's a common metric to be able to include with biodiversity ESG reports, especially when it's on a larger network that we have all this data from. So I think it's really important to share some of those results preliminarily. We've already gotten the peer review back from one, which was great. So we've got a lot to work with. For that, we took an approach from young scientists, diverse beekeepers. So unlike today's webinar, again, with two white guys, that paper was not majority white guys. And that is something that had a lot of really interesting approaches. We were looking at the microbiome of bee guts. So all the bacteria, all the fungi, all the viruses. We looked at a fungal infection called nosema. We looked at habitat nutrition, looking at the genome of all the plants in an area. Everything we could think of, we threw every method at our bees with the blue zones, looking at why our client bee hives doing well where they are, why are they failing where they are, and the end result was varroa mites. So everybody knows this already. Mites are a huge problem, and I think it's still really exciting for research to be able to reconfirm this in an ever-changing world with new perspectives and new technologies there. That's what Best Bees is staying on top of. So we were able to validate that, yes, but our approach was very, very unique, and it's something that's still a major grand challenge in the modern world. How mites are impacting pollinators. We know that mites and other pesticides and pathogens can jump species of pollinators. So where they're impacting honeybees, they can also impact other species too, even if it's not the mites, it's other things. So my staff scientist, Emily at Ithaca College, says, I'm over saying this line, but when I die, on my tombstone, it will say, "Here lies Noah, plant a flower," because on the flip side, while mites are why our bees are dying, why they are living where they are in blue zones does seem to be from their habitat, their foraging. It's the plants. So here lies Noah, plant a flower, and now a third line, it was the mites.
It's so sad, but also wow, that's really helpful context, I think, for myself and listeners to hear. One question that came up from the audience on this topic, which I am curious about, how do we count our mites, or how do we report on that in the software that we use? Nate, I bet this is a question for you.
Yeah. So there's a couple different ways to do what we call a mite wash. Essentially, you take a sample of the young workers inside the hive, and you can do powdered sugar or you can do an alcohol wash. And then that's usually, that's based on a half cup of bees, so about 300 bees. And then we do, after we wash them, you can physically see the mites and you do a count. And then we have a separate form where we take that number and we enter it in, and it gives us a percentage of infestation. I was actually just looking at the spreadsheet yesterday from this past season. So we have a standardized method to do an alcohol wash, count the mites, put it in the form field. And that's basically how we record it in Buzz.
Wow.
And let me just share one other thing too. We published with an amazing researcher, Marla Spivak, who's an expert at hygienic bees. And for decades, Marla and her team at the University of Minnesota were breeding hygienic bees that can naturally withstand mites. They groom one another. And so for the longest time, I mean, our beekeeping practices have always been guided by research. So for the longest time at Best Bees, we did not use any mite treatment because we followed the gold standard, which was Marla's work. And then I heard on NPR while I was driving one day, and I had to pull over. Maybe some of you have had these NPR moments where I heard Marla in an interview and saying that even though she's continuing that work with breeding varroa resistant mites, she now had to treat. And that's really what helped us evolve our practices, because we're rooted in science, we're connected to science directly. And so that always makes sure that we're at the forefront of whatever these changing factors are.
Amazing. Well, I'm going to scooch us over to the next learning topic and keep us pacing along. A much more positive one, I think, or personally. So let's talk about queen bees. We know how important queen bees are to the overall structure hierarchy of a hive. What have we learned this year? Noah, I'm going to let you start. What have we learned about queen bees?
So queen bees are amazing. There's so much to learn from them. And I'll just kind of plug one of my keynote topics is that there's so many leadership lessons from the hive that we can learn. And just like being a CEO myself, people think CEOs need to know it all, just like queen bees are in control. These things are not true. In fact, I just ask a lot of questions. And I think for the queen, certainly a lot of the bee health relies on the health and the fitness and the fecundity of the bees. Like we covered those terms from evolutionary biology earlier. What we've started to do is queen rearing, it's called. So of our survivor stock beehives at client sites, we're able to then look at the healthiest ones, the gentle ones, the best honey producing ones, with the lowest mites, and make more queens from those. And so we're building what we call institutional knowledge across the Best Bees network of beekeepers to learn this practice so that we don't in the future have to bring in any new bees to any neighborhoods. We're already working with what bees are already there and they're established. We have had great success, like Emily, staff scientist in Ithaca, who's had extra queens this past year that we've been able to give for free to the community. So thinking about economic justice, social justice, environmental justice, all of these are benefiting from our client beehives with the survivor stocks that can then be a source population to replace any dead beehives.
Wow. Thanks, Noah. Nate, what do you think?
Let's see. Well, what I think initially is to say that the bees know best, right? So if my learnings this year from queen bees was that sometimes they know best, but they don't always do what you want them to do. So we had a great spring. Fall, the honey flow came on early. Our bees built up super quick. And in an effort to let the hive choose its next queen, a lot of times we weren't squishing queen cells. So when you go into an inspection and you say, okay, this hive wants to swarm or it wants to supersede, and you say, oh, they have lots of queen cells, that means they're going to have lots of options for queens to sit on the throne. And the best one is going to will out and be the healthiest one there. But what we saw was that they probably had too many options, and we were getting these what I call micro swarms. So a swarm is when a colony sort of divides itself in half and then flies away. It's how colonies reproduce in the wild. And we were having that, and then there would be subsequent swarms after that with another one of these queens. And so we're going to amend our management approach to that next year. But that was our learning about queen bees this year for me.
I love that. And a quick plug, we're deeply rooted, and as we've mentioned, social justice, environmental justice. There's a great team that I've been on the advisory board for called They Keep Bees. And that's a wonderful queen rearing school that's available, especially to the BIPOC community, to anybody in the United States, probably beyond, but deeply rooted in the US, to try to learn and share these techniques to spread knowledge. So check them out, They Keep Bees, or reach out to us and we can connect you if you want to amp up your queen rearing knowledge.
Amazing. All right, y'all, let's hop to our final learning, which I feel like this topic is like almost too broad, but habitat and water, two essential needs for all living things. What have we learned about these two elements and how they impact bee health? Nate, you first.
Okay, well, I'll take it down to a micro level and I'll just give you one specific example. So I was telling you about how we have beehives in different corners of the country, and we have beehives on both the rooftop and on the ground level. And one scenario we had this year where it got so hot on the roof for a period of about a month and a half, where we actually had to move it around the corner and into the shade and provide it some water. And you say, okay, well, why are you going to do that if it needs water? Well, that was a short window of time. And there's a much bigger benefit to having hives on rooftops. And one of those gleanings from this year was that a certain tube pest, actually, small hive beetle and wax moth, generally don't make their way up to the roofs as much. And that can be a sort of pressure for a hive, just sort of waiting in the wings. Generally, small hive beetles and wax moths won't kill a hive, but if it's weakened, they might move in and just put additional pressure on that colony. And then now you have a hive that's suffering because of an infestation. But our rooftop hives, we really don't see that as much. But we might notice that, hey, we got to put out water because water's everywhere, but sometimes it can be scarce. So that was our year with habitat and water at the micro, sort of the hive level.
That is so cool, Nate. And, we have been seeing for years now an urban beekeeping effect and bees doing great, typically on rooftops. Now we're starting to understand why through this approach. It's a reason why we also really don't have one beehive per site. We're pushing so far away from that 2 beehive minimum. A lot of sites have 3 or 4 beehives now. We don't want to overcrowd and add too many. But if you have just one beehive, then we can't really see, well, what was it, just that beehive, or is there something unique about this site? Were the multiple beehives affected by these pests and pathogens? So those observations are really important. And I think when you're collecting data like we are directly from each site and analyzing it in-house, we can be really rapid with our response for how we're going to change our practices, how we're going to work with our clients and really inform them, and how we're going to work with our partners. So one of the things I'll add here too with water, with our honey DNA project, we've been doing this since 2015. We launched this at MIT. It was really fun to start to see some of those results be water plants like water lily. We never really understood this connection between how pollinators on the land can promote plants in the water that can clean out water systems and provide habitat for fish. Everything is interconnected. I gave a talk at the New England Aquarium years ago with my great friend from grad school, Randy Rochen, called The Bees and the Seas, for how her coral reef restoration and preservation really related to on-land pollinator health. So there's so much more we can do. And we really like to work with the United Nations Sustainable Development Goals, the UN SDGs, to really help drive home these impacts. We've got a white paper on the topic, how Best Bees Beehives advance at least 10 of those SDGs. So reach out anytime for those or check out our website for more.
Amazing. All right, guys, this was so fun to learn about what you both have learned this year. I am really excited to get into the discussion portion. We don't have a ton of time left, but what we've done to kind of warm up Noah and Nate before we open up to public Q&A questions is I've come up with 3 questions that Noah and Nate have not heard each other's answers for. So I'm excited they'll get to kind of hear each other's thoughts for the first time. And these are going to be our nice little warm-ups before we get into everyone else's questions. So with that being said, I'm going to toss this one over to you, Noah, first. What is your favorite data point to capture, study, and why?
So this is fun. Thanks for doing this, Delaney. I would say that my favorite one has to do with me being a little brother. So for any of you kid siblings out there, if you had an older sister like I did, she would kind of show me when it was okay to approach and when it wasn't. And I really love seeing which beehives are extremely docile, because many people worry about safety with bees. I always say aggressive things is a bad business model. Number one, that business idea would not have worked if our bees were aggressive. So we like very, very safe and gentle bees. And personally, don't share this, I like to go beekeeping without a beekeeper suit. Sometimes I don't wear a shirt. I know this is crazy, but it's just me and my bees. So when a beehive is super duper gentle, I pay attention to that. And I see in the notes anytime somebody mentions that, because I want to breed from those queens so that we can really live in harmony. When we live in cities, these are the built environment. And when we're building buildings, we can keep building those in ways that can improve pollinator health. It's part of what I loved about working with Neri Oxman at MIT, how we can have architecture that makes nature better. So when we can do this in ways that everybody gets along so well, I love getting inspiration from that. So anytime there's a very super gentle beehive, I want to go in there for research and study why.
I love that, Noah. Also, the visual of you shirtless beekeeping. We'll have to revisit that. But Nate, what about you?
Man, not nearly as cool. Let's see. No, this was a new data thing that we started collecting this year. It's called Next Visit Needs. I'm really proud of it. And I'll just tie it back to the concept that anytime we look at the data, it's a conversation from a beekeeper at that hive from that visit. And what Next Visit Needs does for us is communicates what that beekeeper thought the hive needed. So that's a training aspect for me as we develop our bee school and internal training. But it's also like going beekeeping with a grocery list. You're going back to the hive with a list of things that you need. And it can seem really straightforward and simple, but as we make that a little bit more complex in terms of what the beekeeper can put in there, in terms of protocols and just equipment, whatever it might be, it's starting to develop and become this really nice thing that says, okay, I can tell what's going on in my at our hives throughout the week just by what's popping up on the next visit needs. So that's my favorite. Maybe it's just for me, but there you go.
No, that's super interesting. I think it shows the quality of beekeeping that we do provide and how informed every visit is that our beekeepers are doing. So those beekeepers aren't showing up empty-handed. They have all this information to inform what they're walking into. So that's really cool. All right. What is the most fascinating thing you've ever learned about bees, Nate?
Okay, I'll be brief. I joined a study group a couple weeks back, and they pose these questions every day. And they say, check this out. This is something you've never heard about bees. And that's one thing why I love beekeeping. It's just, there's always something else to learn. So we know bees communicate a lot through a dance language. And I thought I knew all the dances, but there's one called the tremble dance. And the tremble dance, you're shaking your head. You haven't heard of it, have you? The tremble dance is when a forager honeybee comes back with a load of nectar in her honey stomach, and she goes to hand it off to sort of a food storer bee. And when there's not enough bees to receive that nectar that she's bringing back from the field, she will start doing this little tremble walk around the hive. And the more bees in the colony that are doing that, actually triggers something. It's a mechanism where the bees will now change their behavior and stop doing what they were doing, whether it was cleaning cells or feeding brood. And they will come and say, hey, we need to stop collecting so much nectar because we don't have enough bees to receive it on this end. And it just changes up the whole dynamic. And I've seen this in my hives, and it just like a light went off, and I said, that's what's going on. That's a tremble dance. It's like just kind of shaking a little bit. And so, yeah, I think that's most recently, that's like my favorite little factoid that I learned.
You're going to do it, right?
I didn't do it.
I think we need to do a whole webinar on bee dance moves.
Dance.
That sounds.
It's like that. I don't know. They're just kind of like, they tilt at like 50 degrees and they kind of like waggle back and forth. And then when they went, so to follow up on that, then another bee will come around and they say, like, stop doing that. We have enough bees now. Another bee will come by and just bop it on the abdomen. And I was just blown away that I had like no idea.
Amazing.
Well, I'll add to that, which is change management, leadership structure, so many lessons that honestly we see in the workplace all the time. We can learn from bees. They've been around for 100 million years as a complex society, almost a corporation that have competition in the industry with other beehives and pollinators. There's so much to learn there. And I've really been amazed at how many like corporate retreats and keynotes hire us to come and give these talks and to understand how change management can be empowered from any worker at any level of the organization to drive huge change, like for bees moving to a place to live. It's been really cool to see people respond to that stuff. And I just love that people are interested and that we get to talk about it.
So cool, Noah. All right. Last question before we use up the last few minutes of our time with some public questions. What's your vision? What's on your vision board for Best Bees data over the next 10 years? Noah, you first.
I love this. Well, I'm going to share. I mean, it's amazing to see beekeepers all around the world. It's amazing to see people, whether they're homeowners or companies or institutions or governments, who want to get those beehives to their property. It's great. Anybody can do that. It's very democratized. What we at Best Bees have been doing that's different, I hope that you get that picture today. To sum it up, we're standardized beekeepers. We've built a network of these data yielding beehives. And where we're going with this is a very high-tech term called blockchain. When we can link up all of these beehives with another technology called machine learning. We have these data sensors in there. It's part of what we're working on with Stanford and Enterprise Neurosystems and other groups at the UN we shared. When we link them up so that anybody can join this network called the blockchain, we can have a lot of trust in the truth of knowing how a beehive is doing when it's doing great, what's killing it when it's not, how those beehives can alert one another. And all of this information is so important for people to join the Best Bees network, because when you're not connected to this, you're just kind of doing it on your own. And it's very rewarding, but anybody can do that. There's really nothing special about that. And you're not necessarily advancing your goals when it's not connected to this larger network. So that's where Best Bees is going. It's been amazing to do it. And we just keep inviting everybody to participate and join us.
Amazing. Nate, what about you?
Okay, so this is what happens when you don't like share your answers. I mean, it's very similar. I see our hives being more connected with sensors. I see AI sort of starting to predict and flag hives that are saying, hey, we know what kind of winter we had, so we know that how that's going to set up the spring. And based on your location and the report of how strong this colony is healthy, it's going to need an extra box, it's going to need 3 more frames, and you're going to want to get your mite treatment on by 1st of July. So it's connecting hives with sensors, and then that's just aggregating like unbiased real-time data. And as we start to look and map climate change, it's going to be really important that we're like able to respond quickly to sort of the changes in how that colony evolves through the season, because it's going to be different. It's going to be something that they never experienced before. And that's why as a managed pollinator species, we have to step in and be that steward. So connected hives, AI, it's all great. The future's bright. I love it.
So cool. All right. Well, we have truly used up all the time having this amazing conversation. There is a lot of questions in the Q&A. So what I will say right now is we'll take another 2 minutes to answer Q&A questions, but we will follow up an email to make sure everyone's questions get answered. And all registrants for this webinar will receive a webinar recording. And with that, we can potentially try and drop some of the most asked questions in there and drop our answers in there for you guys as well, just to make sure everyone's questions are getting answered. But for folks who might have 1 or 2 more minutes, we'll try and get a couple quick questions answered with quick responses, if that sounds good to you, Nate and Noah, just to get some answers out there. So we get this question a lot. Noah, I think this is a great one for you. Should we be concerned that honeybees are putting pressure on native bees? Is there competition between bees that we should be aware of or be conscious of?
Such a great question. I love how much this conversation has evolved from the early days when I started my PhD in 2005, when people would say, why are you working with bees? What's a bee? Now, what species of bee? Yes, this is great. This is the discussion that we need to be having. What are those other species out there? It's precisely why we exist. It's why Best Bees is here to do what we do. We're trying to collect data to advance pollinator health. Our mission has never been honeybee health. We've only been using honeybee hives because that's the leading research tool to understand how pollinators are doing based on our thousands of years of knowledge, how many people can work with honeybees, and really the amount of funding that's out there, and the honey benefit. So what we're doing is understanding the other species of pollinators that are there. And I mentioned a little bit about our genomics approach from the pollinator flowers. We can see the animal DNA and start to measure their presence because of the data we're getting from honeybee hives. So that's been one thing: measure who's out there, understand how their populations are changing over time, and also understand a concept called the carrying capacity of the land. And this is something that we've always been doing at Best Bees, and understanding hive density when there are a lot of beehives in one area. How do they perform compared to areas where there are not many beehives? Our research has always had counterintuitive results for me. So anytime you guys have seen my TED Talks, I'm sure I'm always saying this stuff. Our research has found the opposite. I call this a positive feedback loop. At least for honeybees, where there are more beehives in an area, they all seem to be doing better. And this is very important because this is in urban areas where there's an abundance of resources. Our research has shown that there are 8 times as many pollinator plants in urban areas compared to their nearby suburbs. So in areas of abundance, pollinators create more plants. They help plants reproduce. Pollinators create more fruit. They help create more flowers. They bring more nectar to the environment. It's like when you go to the grocery store and you buy an apple, the rest of the neighborhood doesn't go hungry. Instead, it builds that business and they supply more apples because they see there's more of a demand. So more research needs to happen here, especially in areas that are realistic. A lot of research has happened in the Canary Islands where there are very limited resources. And yes, honeybees can and do outcompete solitary native bees in those areas with limited resources. So as scientists, we're always looking for the underlying truth. As citizen scientists, we're always connecting ourselves to others to understand what we're seeing, what we're observing. And as scientists, scientists who really value inclusive innovation and publishing in open access journals, we share our data, and we're always constantly looking for what other data are being published to stay on top of this. And what you can see really from Nate's side too, with the product innovation and boots on the ground, we're doing more with native pollinators. We're doing more with blue orchard bees, with habitat in terms of the plants that they forage on and in terms of the sites that they nest in.
Wow. Thank you, Noah. All right. I'm going to do one more question. I'll let you, Nate, answer the last question, and then we'll make sure to answer all of the other questions via email and in the follow-up email with the recording. Nate, this one's fun. And it's actually a question I've thought a lot about. How does a queen become a queen in a hive?
As a queen become a queen? Well, you know, it's one of those things where, like beekeeping in general, sometimes we just logic our way to a answer, and we don't have any other reason to, think it's any bit different. But what we understand about a queen is she starts as a fertilized egg, just like the worker bees do. Now, all the worker bees are female, the queens are female, and then you also have the drones. But a fertilized egg means you're going to get a female. And it's this 3 days after the egg hatches and turns into a larvae. There's 3 days there where if that egg receives an abundance of royal jelly, which is this special protein that is secreted by the worker bees. They have a gland in their head that secretes this like really rich protein-like substance that we call royal jelly. When that egg is is sitting in a cell that's a little bit larger than a worker, and the hive has sort of come to an agreement, and they say, we're going to make a new queen. And I could talk forever about what those different reasons are, but essentially it's that extra increase of protein, as we understand it, during that short time frame, all that royal jelly, a bigger cocoon to sort of evolve into and metamorphosize into this pupa. And then 16 days later, she hatches. She's what we call a virgin queen. She takes a few days to sort of test her wings out. She'll go out on a mating flight, and somewhere around after she gets done mating, she'll come back to the hive, and that process can take about 3 weeks from when she when she first is laid as an egg and to when she's back into the hive and she's laying eggs. That can take anywhere between 3 weeks to a month, but in a nutshell, that's how queen bees are made. The hive decides, we want a queen. We're going to take this fertilized egg. We're going to throw some more royal jelly in there. She's going to hatch. She might have to beat out her successors. If there's multiple queen cells, she'll go around and she'll say, I got here first, and she will open up that pupa and say, you're done. And the bees will clean that out. So it's a really fascinating topic. I'd love to talk more about it, but that's what I got for you.
Amazing. Thank you, Nate. It's incredible. We do have a great blog on this on our website as well. So that'll be the kind of final plug here. Thank you guys so much for coming. Our website is an amazing resource, bestbees.com. You can see a resources tab in the main navigation. We have our blog. We have a whole page of webinars and videos and keynotes. We have another entire page of ebooks and white papers that Noah and the scientific team have written. It's an incredible resource for folks to dig in that want to learn more. We are working to have webinars every quarter, if not multiple times a quarter, open, free for the public, for you all to come and learn more about bees and pollinators and what it is that we do. So thank you all so much. Thank you, Nate. Thank you, Noah. This was amazing. It was really, really fun. I appreciate everyone's time being here. If folks do have a minute after we close out the webinar, there will be a survey that pops up. Let us know what you thought. If you have any feedback, it always helps us to keep improving these public spaces where we're sharing this information.
Thank you.
Thank you so much.
You guys are the
Being
best.
here.
Have a great weekend.
All righty.
Appreciate y'all.